This is Steve Piloff from George Mason University. So sometimes if we have an annuity or an annuity due, we know a lot about it. We know the rate, we know the number of cash flows, we know if there's an extra cash flow at the end of the period, and we know the present value. So we know how much an annuity is worth, we know when it makes cash flows, and we know how many there are, we know what the rate is, and what we want to find is what is the payment, what is the cash flow associated with that annuity or annuity due. Common examples, we have a loan and we know how much it's for, we know when we have to make payments. What is the amount of our payment? We retire with a certain amount of money, we want to be able to collect money for a certain period of time, starting in a certain, either starting right away or starting in a year or in one period. How much can we collect? What's the regular cash flow that can be produced from that amount of money? We're going to look at how to use a financial calculator. You can also attack it algebraically, but the calculator is a good tool in this case. So suppose we are in end mode. So first of all, you tell the calculator PV. So you tell the opposite of what you tell the PV is the present value of your annuity or annuity due. FE, if there's some extra cash flow out here at time N, you're going to tell a time N, which not only tells it when the FE payment is, but it tells you how many payments there are, and we're in N mode, so it knows, okay, there are N payments starting in one period. So it knows that there's these payments. You tell it I%, which is the rate, expected return, or the interest rate on a loan. But what that is okay, we know what the present value is. We know if there's something extra, and we've got all these payments. We know the rate. The calculator will then find the payment such that the present value of all of these cash flows, discount of I%, is equal to the present value that we've told it. If we're in begin mode, it's a similar situation. We tell it the PV, begin mode, and you give it N. It knows, okay, there's N payments. They're in begin mode, so I know they start at time 0. And so the last ones, if there's N of them, is at time N minus 1. Again, if there's some extra cash flow at time N, gets captured by FV, I% the interest rate, and the calculator could then find the payment such that the present value of all this stuff is equal to the present value that we told the calculator. So let's take a look at a couple of examples. So you borrow $20,000 at a rate of 0.6% per month. What's your monthly payment? First payment is due in 1 month, and all payments for 5 years are equal. So we know we're making equal payments for 5 years, and they're monthly, so we know that there's going to be 60 payments, and we know the first one starts in 1 month because we're told that. So first in 1, second in 2, all the way out to the 60th in 60. We know the interest rate 0.6%, and the present value of all these payments is negative 20 because we're borrowing 20, so what we pay back has to have the same present value of what we get. So we want to find what is C such that C over 1.006 plus C over 1.006 squared plus C over 1.006 to the third, all the way out to plus C over 1.006 to the 60th is equal to negative 20,000. So again, there's 60 payments. They start in one period. The present value of all these payments is equal to negative 20,000, so PV is the opposite of that. The interest rate on our loan, or the rate that we're going to discount all these payments by, is 0.6%. Solve for PMT. Our payment is $397.91. Every month we're going to pay $397.91 to the bank. Here's a similar loan. Monthly payment. Oh, actually, it's not a loan. It's a similar situation, but it's presented in a positive framework where we're going to collect cash flows. We want to know what the monthly payment for an investment is worth, 20,000. So what's the cash flow for an investment that's worth 20,000? It will make equal monthly payments for 5 years. So again, it's 4 or 5 years. So right away, it's monthly. We know there's going to be 60 payments, and its first one is later today. So we're going to get a check later today in 1 month, 2 months, 3 months, 4 months, and we're going to do that 60 times. So our last one will be in 59 months. Has a monthly return of 0.6%. Present value of all these is equal to 20,000. That's why the value of this investment is 20,000. So what is C? Again, there's 60 payments. I percent 0.6, because that's the rate we're given. Present value of all these cash flows is 20,000, so PV is the opposite of that. Nothing extra. Begin mode, because we're going to be getting our first payment today. And so we'll be getting a cash flow of $395.54 starting today.